Hello, my name is Goyong Hao and I am the leader for our microprocessor Group 5, and our main project is temperature measurement using the LM35 chip with the AVR microcontroller. I will start with our task distributions. I am going on and I handle overall stuffs almost 50% of the projects, including the programming part and the building of the hardware, software, etc. While I just leave most of the report to Diogen Excel along with the other members as helpers. So what we are going today to do is explain about the LM35 sensors for this project. LM35 sensor is a transistor that will output a voltage that is proportional to the centigrade measurements. So it will start at 0 degrees Celsius and up to its maximum depending on models. The model we use here is about 110 centigrade. Other models have different ranges. For our case is about the water boiling point, and this signal is considered as an analog signals that is used as an input, and we need to analyze this input using the Mega 32A for generating the output for temperature in centigrade, while the output is generated on the 16:2 LCD with the I2C module that we'll discuss later. Here are our list of components. First, are LM35. The model here specific is the LM35DZ. We use 2, but in actuality we use more than that for cases if the LM35 breaks. Next, we have a AVR Mega 16mm system board. This is used for programming the Mega chip, which is provided by our lecturers. Also, for the USASB programmer, which is also attached to the AVR minimum system board, which is also provided by our lecturers. This is the capacitors that we use. About 100 microfarad capacitor and 100 nanofarad capacitor. This is for stabilizing the analog input, so the output will not reduce the noise of the output. This is the breadboard that we use, and also this is a I2C display with 16:2 LCD display with I2C module, which is back here. This one is the I2C module. This part we will discuss later, along with the DuPont wires. This is the circuit diagram of the project that we use. Notice that we use a dial here to simulate a LM35 that will output a voltage based on the current. However, we use a dial to simulate it for testing it, and also the simulate ID that we use do not have the LM35 specifically, so we need to improvise. And also here C1 and C0 pin is a SDA and SCL pin for the I2C. We need to use a pull-out resistor to make it work. Without it, this will not work. The information will not pass. This is the analog reference that we use, but in the programming we use an internal reference, but for our case this is sufficient. And this is a reset for testing it, and also refreshes the values when needed. This is the circuit diagram of top-down version, which is almost the same as above, but with more specific details. This is the hardware that we built. Unfortunately, the photo is not too good, but this is sufficient enough because there are too much wires. But in the end, if the LCD can display the proper values, then it is okay. I would like to talk about the design and functionality of the iWin35. Basically, we set at the connect it as such as above circuit diagram, and we just set it at 8 megahertz, and we use Arduino IDE for this project because we cannot find the specific I2C LCD libraries in ML Studio that will produce the correct output. And given our time constraint, we decided to use the Arduino IDE to skip that process. However, without using the ML Studio, we cannot use the debugging function, and the debugging functions on the Arduino IDE is quite limited. So we may need to improvise for future projects involving this I2C LCD displays. The main parts here is a analog to digital conversion of the LM35 sensors. These are the main parts. There is the NMAX register is for the configure to use the 2.56 volt reference in the reference pin. Sorry, for the reference analog reference. The rest is the mode for the ADC. This is what we find. This is the part that we need to use. And after this, we divide the value by 4, so it will output the correct value. I2C connections. I2C is a protocol, a 2-wire serial protocol to initialize the I2C LCD, and the I2C address is 27 hex. And these are the wire hash and liquid hester hash is the libraries that we use, along with other external libraries that we found out in the testing period. And this part is for the part that I explained just now, just in more detail. And we use the Mighty Core in Arduino IDE because this library can help us to program the ATmega32A. These are the drawbacks